Sometimes we're asked to solve equations that we don't actually know how to solve algebraically, or we don't know how to solve very well algebraically. So if you remember back to Algebra 2, we learned how to take a function like this one here, this function, and we learned how to use rational roots to find the actual the zeros of this. And it took a long time. If you remember, we had to list all the rational roots, then we had to test each one of them with synthetic division to find them. Well, the good news is that there is a way to do this in a calculator. So there are a lot of times when we can use a calculator to be able to find the zeros or the solutions to an equation. So imagine I have this equation, 6x cubed minus 31x squared plus 23x plus 20 equals 0. I have that equation, and I need to figure out where it's true. So what I'm trying to figure out is, where does this function equal 0? So don't you think I could just graph it, find where the function equals 0, and there are my answers, right? So that's what I'm going to do. I'm going to graph it. And when I graph it, I get this crazy cubic function here. And I look, where is this equal to 0? Well, it would be equal to 0 here, here, and here. Those are the x-intercepts, the zeros, the solutions. Those are all different names for them. But basically, that's where the function's equal to 0. So I can just calculate that. I can go to second, calc, which is above the trace, and I can calculate a 0. So I push enter, and it asks, where do you want me to look? So that's what this question is saying, left bound. It's saying, tell me the farthest left that you want me to look for this 0. So we have to kind of put a little box around the 0 that we want. We need to go to the left and to the right of the 0. So I'm going to, you see the little cursor? And this tells me where the cursor is. So I want it to the left of this 0, so it's not quite to the left. So there we go. Now it's to the left of the 0, so I push enter. And it made me a little line there. And so then I go to the right of the 0, and I push enter. And then it asks, can you guess where it is? Well, I'm pretty close, so I'm just going to say, okay, there. The first 0 is at -1/2. That's where that 0 is. Okay, let's calculate the second one. Second, calc, 0. And now we're going to arrow over until we're to the left of the other 0. Now, if you watch this, it tells you where you are. This tells me I'm at y equals 23, and now I'm coming down, 22, 19. See, it's coming down closer. It can be anywhere to the left of this 0 as long as it's in between this one and this one. We wanted to have this little box so that it only encompasses this 0. So here we are to the left of the 0. Now we're going to go and do the right bound to the right of the 0, push enter again, and this 0 is at 1.666, which is 1 2/3. So that's that 0. We're going to calculate the third 0, calculate 0, and we're going to go and anywhere again to the left. So I'm going to go right there just because I don't feel like going, trying to get really close, and I can. Oh, and there it goes. Did you see it? Did you see it? Below, above. All right, now it's to the right of the 0, so I push enter. And it calculated that 0 as 4. So that's it. That's the easy way to find a 0 on your calculator by just calculating the zeros. Now, sometimes we're going to have an equation that looks like this. You're going to have the absolute value of 2x minus 4 equals 6. So I wrote it on there. There you go. Equals 6. So imagine you have that function on your calculator, or not on your calculator, on your paper, and you want to solve it, okay? So you may already know how to do that with algebra, but there's a way to do it in your calculator because there's some of these that are just too complicated to solve. So we can say, well, we want to figure out where this function equals this function. So this function is the absolute value of 2x minus 4, and this function is 6. So I can put each of the functions into my calculator, this first function in and this second function in, and then I can graph them and I can find where they're equal to each other. So where is the blue function equal to the red function? Well, right here and right here. So I'm going to calculate what those points actually are. So I go to second calc and I calculate the intersect. The intersect means where do two curves intersect. So I'm going to push enter and it brings up this. It says, which curves do you want to look at? What's the first curve? And it's already on my first curve. It's already on the blue curve. So I'm like, yep, I push enter. That's the one I want. And then it says, what other curve do you want to look at? And I say, yep, the red one. That's the one I want. And then it asks for a guess. And I say, I'll move it over a little bit so it kind of has, there we go. I I think it's somewhere around there, and I push enter. And there we go. The intersection of this one is at x equals -1, y equals 6. So one of the x's that makes this true is -1, right? Because we're looking for what x value would make this true. 2x minus 4, absolute value of 2x minus 4 equals 6. One of the x values that makes it true is -1. The other one we can calculate by going to calculate, intersect, and asks first curve, second curve, and now for the guess, I'm going to make sure that I'm closer to the other intersection, because otherwise it's going to calculate the one I already know. So I push enter, and it found the intersection of 5. So 5 is the other x value that makes this true. If I put -1 in here, it would be true, or if I put 5 in here, it would also be true. So those are two simple ways to use your calculator to find the solutions to any equation.